I'd like to introduce from IBM Scott Baker. He's Chief Marketing Officer. He leads the product marketing team, quite recognized in our industry as a technology leader. He's the voice for IBM server storage, technical service products and solutions into the market, and has really made a major impact in terms of branding for IBM storage. Over the last 25 years, Scott has held senior level positions with Pure Storage, Hitachi Vantara, HPE, NetApp, and EMC. Prior to joining the storage industry, he has quite a background, both in startups and also as a software engineering manager for NASA, and he served in the U.S. Army. Scott holds bachelor's and master's of science in computer science degrees from Columbia Southern University and an MBA from the University of Northern Alabama. Let's welcome Scott Baker.
Hey, thanks. All right, so I'm supposed to tell you about the new IBM Personal Computer 3 as a segue to the video that you just, I'm not going to do that. I do have a unique opportunity, though, to spend some time with you talking about what we're seeing as maybe some of your consumers, how we take the technology that you're coming up with and the ideas that you're developing right now, and we look for opportunities to push those further down in the technology stack. It's something that's very important to us because in today's presentation, what I'd really like to share with you is some of the innovative thinking that we're doing. And here's the best part. It's not a real product yet. We don't have it right. I want to float this idea with you to see what your thoughts are. What can we do to help make every bit of an organization's data available to them in the most secure and most insightful way possible so that they can take some kind of informed action on that data? Now, I will profess that I started off as an engineer, but quickly made my way through the ranks of trying to figure out how, when you hit compile, somebody convinced someone else to spend money on whatever it is that I was asked to create. And then, how do you drive strategy around that? And what I like about the aspect of IBM that I have right now is an opportunity to engage with customers. And what I would share with you a little bit up front here is some of the drivers that have resulted in the conversation that I want to have with you today, especially as we think about ransomware as a major problem for organizations and what we can do from a computational storage perspective so that we take onus and responsibility off the host where necessary, certainly off the controller where necessary, and we allow that computational activity, the entropies that we may be using and looking at, the trending and forecasting we might be doing with the I/O patterns, and apply that where the data sits. Because I will tell each and every one of you, from my perspective, the flash drive is the true data custodian for an organization. And that implies that we have a responsibility to help that drive do the best that it can possibly do to save that organization's data and certainly safeguard and protect it. Now, most of the people that I engage with are often on some kind of digital journey, whatever that journey may be, and how long that journey is going to take, it varies. But they have three stumbling blocks that they often run into. And the first one is always around, how do I continually optimize my IT investment and my IT infrastructure so that I can continue to operate and behave as if I were a cloud-like architecture running on-prem? Kind of back to what Matt was talking about, this development of the cloud and the abstraction and the use of the cloud and the distribution of IT resources means that organizations aren't looking necessarily to adopt an external cloud in as much as they're trying to operate internally as if they are their own cloud provider. From optimizing IT, it gets into how do we turn ourselves into a hybrid cloud where you've got consistency between what happens on-prem and what happens in the outside world. I'm not a big fan of the term hybrid cloud because that's just a deployment model. What's really hybrid are the applications and data. The obligation that we have here is to create a foundation by which applications and data have bidirectional mobility between the cloud and on-prem. That creates that hybrid cloud architecture that we're after. And that's often where organizations will also hit their second obstacle, is how do I create a hybrid cloud experience that not only can I seamlessly connect to the cloud, but then how do I take that connection and make sure that the data movement is secure and consistent? Because ultimately, we're trying to create an information supply chain for the organizations that we service, where they treat information or data as elements of that supply chain that get delivered to parts of the business for those actions to be taken on. And certainly, if I can create a hybrid cloud, then it stands to reason my focus shifts to operational agility, where I'm looking at applications and services as a form of delivery mechanism and not worrying so much about maybe the compute or the networking and the infrastructure layer, because I've already got that locked up, autonomized, and ready to go. So as we engage with our customers, here's what I'm finding more often than not that drives them, on their future directions and decisions about how they're going to adopt technologies like flash memory, especially flash memory-based systems that have integrated ransomware capabilities to them. We expect that by 2025, based on the feedback and the surveys that we've done, that 60% of the organizations today looking to purchase storage arrays are going to be looking for arrays with features that are reminiscent of being able to safeguard and protect them from ransomware attacks, working in concert with the other technology stacks that are operating in the organization. We also know that there is a shift toward the hybrid cloud. So we know that 60% of the organizations that we're communicating with today, by the time we hit 2025, will be fully hybrid cloud enabled, looking to move those data sets and those application stacks from on-prem and into the cloud, being able to move from the cloud back on-prem as well. We also know that edge-based computing is going to increase. And for me, an edge is, it could be the drive. The distance between the drive itself and the controller is an edge-based association when you've got computational storage at your disposal. It could be at a remote office or a branch office. The important thing to note here is that anytime you hear the term, what's your edge solution, we always say, well, how do you define edge? Because some people will say it's a sensor running on a telecommunications tower, and it's reporting the temperature and whatever signal patterns it's reporting. Other people will say, well, it's a remote office, branch office, or it's a managed service provider. We also know that unstructured data is going to continue to rise, right? And I don't want to detract that from today's conversation with you, but the simple fact is it's the simplicity of creating assets that are unstructured in nature and the necessity for organizations to store those assets create the scale problems that we often run into that prevent people from creating that hybrid cloud architecture. And of course, my favorite one here is, let's close off on something that really matters to all of us, is the use of NVMe over Fabrics workloads. I would have thought by now the all-flash data center is a reality. I would have thought by now everybody was running NVMe over Fabrics, but we're not quite there yet. And so we're continuing to see this maturity and this adoption. And I think a lot of that from our own customer interactions is propagated by the simple fact that they have legacy IT systems that are in place that they still need to operate, whether that's to service critical workloads that they rely on, even if it's just to read the data, but they're not always there to make a complete switch over to an all-in NVMe Fabrics-based solution. I will tell each and every one of you that NVMe over TCP is something that is on our own personal horizon, but from our customers' acquisition perspective, we still see a big use of the Rocky V2 for those NVMe over Fabrics. Not to say that that's slowing down our innovation, but as we think about how we prioritize, we're looking at where the adoption is so that we can get the most benefit for the customers that we service, as well as balance the engineering resources that we use as we think about the other features that need to be implemented to support our customers. Excuse me. But anytime we talk to anyone about digital innovation, it always creates risks for them. And when we're talking specifically about ransomware, I would just share some common stats with you that I often see. That 61% of the customers that we engage with, whether they are IBM customers or someone looking to do work with IBM, will tell us that they have been infected or are currently battling a ransomware or malware-based infection. If we look at the mid-market, which is interesting to hear IBM talk about, is how do we penetrate the mid-market in the small to medium business, we know that in the mid-market and below, those companies that get impacted by malware attacks, where the outage has sustained enough of a lack of access to data, that they will shut down within about 6 months once they get hit with a ransomware attack for which they either cannot afford to pay for, or the length of time that it takes to restore, or the amount of data that they get back is not enough to get their business back in operation. We know that on average, in the best possible situation where all of the run books are printed out, updated, and people practice and drill on this, that on average 30 days worth of downtime actually occur associated with a ransomware attack. I would also say that when we look at restoration operations, if you have any experience with backup and recovery, we all know that backups work 100% of the time. 100% of the time your backup operations will work. It's the restore operations that are always questionable, right? That's what a backup administrator would tell you. But we also know that from a ransomware perspective, getting the data back can be a little bit problematic, though I would argue that the threat actors that are out there probably have the highest NPS score, because if they get identified as somebody who does not give you your data back, then your willingness to try to engage with them, should they attack you, gets relatively low. But still, getting the data back, and certainly getting all of it back, can be a bit problematic for organizations that are out there. And then last but not least, when we look at customers who look at the impacts and how they handle a ransomware attack, the impacts that that has with the vendors that they, or consumers that they rely on, it can be detrimental to their business. I would say probably the last thing here that creates risk is the willingness for organizations to pay the ransom, because that propagates the problem. In fact, when you look at threat actors, they're becoming even as complicated as the malware that they're unleashing. They understand that most organizations follow a 30, 60, 90-day plan when it comes to how they do backup and recovery strategies. So they set up cyber farms. They'll drop malware in that's time-locked. They'll let that gestate. Maybe they launch it on the 100th day, knowing that it's made its way into all of your backup sets. But imagine if we could take the technology around detection, correlation, and entropy calculations and apply that at the drive level, so that the drive was always looking at how do we safeguard the organization. And thinking about that from the perspective of doing it from a block-based system versus just relying on a file-based system, I think adds some complexities that I'm pretty excited to share with you today. And most of the organizations that we engage with will tell us, don't worry, Scott, we're okay. We've got a security framework that we follow. I'm not against frameworks. What you're looking at is the NIST framework here. And in fact, what IBM does is it provides solutions for customers for every stage that you see there, whether that's a cyber resilience assessment that we offer freely to customers. It's vendor agnostic to help them identify the level or the degree of the attack surface that they have, with a prioritized roadmap of how they can close that up. But what gets interesting to me is, how do we help them protect the environment, actually set up the defenses? We can do that with immutable snapshots. That's cool. We could certainly do that with backup sets that are air-gapped and isolated from the rest of the environment that they could recover from. And we can actually put in some validated and verified points of restore solutions that will help them out. Because most people in the traditional enterprise storage industry sit way over on the right-hand side, where it's all about rapid response and recovery. I want to prevent the problem from occurring to begin with. I want to use the relationship that we have with QRadar and Guardian from IBM Security as a way to constantly monitor the human-to-machine interactions and the machine-to-machine operations, looking for anomalous behaviors that then drive down and either correlate activity that we see from the storage perspective, or tell the storage array itself to do something. In fact, if I were to show you what that would look like, what you see on the screen here would be our flash systems. This is based on our flash technology, what we often refer to as the flash core module. And in any traditional kind of deployment, we've got some volumes of data that have been, or volumes that have been allocated. And the one that you see in the lower left-hand corner that's sort of blue, not necessarily black, is the production one that we're going to talk about. What we do is we use a feature called safeguarded copy that creates secure and immutable snapshots that then get stored in an isolated recovery environment right there on the array. What's interesting about that is that they are not only immutable, and they are also isolated, which means you can't change them. And if you need a first point of recovery for crash consistency, we have that available. And we'll create these copies on whatever the snapshot schedule is. They're space efficient. It works really well. But let's just say that there is a problem in the environment that QRadar and Guardian may have picked up on. They may have detected some kind of malicious activity going on, or abnormal activity that's going on, and triggered a snapshot to get created. That's that snapshot number 3 that you see popped up there. And what happens is that we'll kick off this cyber recovery tool. It's a secure and operationally air-gapped environment off of the storage array itself, where a copy of the last known snapshot is moved over. We run it through a series of microservices that will scan and analyze that set of data. We'll actually make sure that that data can be recovered from, before we then send it off to a set of tools that will test and validate that you can actually restore an application back into production from it. In the event, though, that we should find that there is a problem, either in the analysis or scanning, or that you can't restore the operations from it, we'll kick it off to an isolated workbench for forensic analysis. And we'll run through this process multiple times until we get the last known verified and validated point of restore for the organization to recover from. Once we know that, after we've done the scanning, we'll stick it into a restore point location, tag the metadata, so that your backup administrators know exactly which restore point they can get that is devoid of any kind of threat signatures and is application consistent in recovery. And my favorite part is we can also put it into a physically air-gapped solution. So now if you rely on tape-based architectures, you don't sort through the tapes to figure out which one you're going to restore from. You simply just ask the tape system to give you the last known good copy that was devoid of threats. And I share all of this with you here because what I'm sharing is above the device level right now. It works with the flash system, sure, and the flash system features are doing stuff on the drive. But at IBM, we're always trying to figure out how can we get some of this above the controller or above the array activity and encapsulate that as back-end service processes that can be ran either on the array itself in the background or on the drive. And that's what I want to talk to you about today. As we've gone through and we've looked at cyber attacks and engaged with customers who are having issues with either being the victims of an attack or certainly an ideal candidate to be attacked, it gave us an opportunity to do a lot of engagement with the IBM security team and those customers to understand what does an attack look like to them. Because ultimately we need this information to decide how we train the underlying technology to be able to respond. And we know that somewhere along the lines, and a threat actor is going to compromise the environment. They're going to infect as many files as they can. Part of the infection will be to escalate the access to the rest of the IT environment so they can propagate whatever that infection is. Then they do the scanning, then they'll do the encryption or the deletion, whatever the case may be, and then they launch the attack full on and they require payment. And the goal here is to make sure that every one of our customers and your customers never see this screen. We don't want them to know that they've been infected with some kind of a ransomware because we want to make sure that we found that and we've absolved them of having to deal with this kind of a response. So here's the way that we typically see ransomware happening in the market today. The first one is certainly the threat signature, where we're taking a small snippet of the hash of a known virus. So we're storing that in a database, and then we'll compare malicious activity snippets against what those known actors are, or those known signatures are, so that we can then say this is in fact or is not in fact a piece of malware. And the problem with this means that you have to know what that snippet looks like. So this kind of an approach, while effective for most hosts, doesn't help us with zero-day attacks or certainly metamorphic attacks where you've got variants of malware that are just off by a little bit, enough to make sure that the hash isn't the same so it goes undetected. What I want to talk to you about is what we're doing to look at data behavior signals, both data patterns from an I/O perspective as well as data heuristic perspective, and especially doing that at the block level so that we can start looking at entropy and the changes that are occurring in those I/O patterns and then drive these signals back to the controller to say, hey, there could be a problem here. And we'll talk about how we do that, especially when we start thinking about data traffic signals. How do we take data behavior patterns and data traffic signals and marry those together to look for correlations as we compare those against average entropy windows themselves? So I'm going to talk specifically about the data behavior patterns at this point. IBM partners with a number of network providers. We certainly partner with a number of ecosystem providers for security software as well, and they'll certainly help us out with the threat signatures and the traffic. Now, if you had an opportunity to sit through my colleague's presentation around the Flash Core modules that he would have done earlier this week at the summit, you'd have heard him go on ad nauseum about the value of the Flash Core module that IBM produces. I'm going to share a couple of data points with you here just to sort of set us up before we step into how we're using this. But on the Flash Core module, it is based on industry standard QLC from a processor perspective with some SLC paging technology inside of it that allows us to move hot data into SLC pages for performance and colder or warmer data into QLC-based NAND that we can store for longer-term usage or pull it back into SLC when it becomes hot. And that's that smart data placement there that I have on the screen that handles that movement between SLC and QLC. One of the things that I'm really excited about our Flash Core modules is we do consider them to be a form of computational storage because we're using the ARM-based FPGA processor as an offload with its own memory and its own processing capabilities to do things such as inline compression or hardware-accelerated compression, maybe deduplication, encryption, et cetera. And so what we found is that there's space within that processor that's going to allow us to do more when it comes to thinking about entropy measurements, data patterns, and forecasting to indicate potential anomalies. So we can do crazy kinds of reads and writes. We can certainly do read-write amplification controls so that we can get better durability for the technology itself. And then certainly as we think about error corrections and that long-term durability, mitigating the impacts of write amplification so that the drives have less error conditions to deal with, we've certainly put all of those technologies in to include driving the lowest cost that we possibly can to prevent drive burnout, et cetera. So the technology itself, I'm a big fan of actually seeing it versus the marketecture stuff that I'm often asked to put up there. So you're actually looking at the exterior of the drive itself today, supporting between 4.8 to 38.4 terabytes of physical capacity with a 3-to-1 hardware compression algorithm that'll get you anywhere up to 116 terabytes of usable capacity on those larger drives. It is based on the PCI Gen 4. That simply just, to me, means we can move data much faster and we can support more workloads. And then the last thing, too, is the fact that the latency at 50 microseconds or less, I think, is a very powerful enterprise player, especially when we're talking about a drive that's based on top of QLC that's operating at its optimum performance and capacity limits. Now, if I were to take that thing with a crowbar and break it open and peel it apart, this is what you would see inside. This is a folded view. Well, it's in the unfolded view, I should say. The unfolded view of what's inside of our drives, calling out the FPGA processor there in yellow, the associated NAND technology that we're using to store those drives, and then the memory that we've called out there that we can handle the caching, the reads, the writes, et cetera, to service those out. And then the capacitors in the yellow there that I really didn't give any attention to. Capacitors never really get any love in storage. I'm just going to tell you, I know they're really important, but we don't really talk about them enough. All right, so here's the vision. And again, I just want to preface this. This is not in market today. This is an idea that I want to share with you. I think IBM is full of ideas and we don't share them enough. We tend to hold on to those ideas too long. But I want to share this with you, and so do my colleagues, because we want you thinking about this as well. When we think about who our NAND suppliers are, when we think how we engage with our customers and make recommendations, they're looking for these kinds of programmatic technology capabilities within the underlying storage media to help alleviate problems. What we're looking at here is how do we start looking at the entropy of the patterns and the activities that we are asked to do from a storage drive perspective. Remember I said we have hardware-based encryption. So being able to, and compression as well as the deduplication capabilities. So now imagine being able to start looking at pattern changes with respect to compressible and non-compressible data. Imagine being able to look at the signals coming from the drive itself where maybe they're not as uniform in nature, they're more randomized, which indicates the drive is operating normally, the data throughput is operating normally versus a drive that might be impacted by malware which would have a more unified or a uniform set of signals that were occurring. Imagine being able to take now the frequency of bit values, right, and looking at the distribution of those bit values for uniformity as a means to understand how the data set that's being laid down onto the NAND drives either matches or does not match activities related to ransomware attacks. Also taking a look at how we're doing logical block address sequencing, right? Are we being asked by the host to do things that are outside of historical norms for that host? And then last but not least, those reads and those writes. Not just looking at the reads and writes as they're coming in that very instant and moment in time, but how does that compare to the way the host normally sends read and write commands? At that point, we begin to look at things like, is this a malicious attack? Is this a data exfiltration problem, et cetera? So the way that this would work for us is that all of the things that I just mentioned would act and behave on the actual FlashCore module themselves. We would use not only data pattern matching, but also data heuristic pattern observations. And we would send those up to Spectrum Virtualized, which is the operating environment that drives the flash system itself. That operating environment has its own inferencing engine. And so the things that we would tag from a drive perspective that were anomalous, patterns that fell outside of established norms, would be dropped into this inferencing engine that would be correlating and aggregating information from other sources. Using machine learning, we would then determine, is the pattern really an anomaly? And if it is an anomaly, is it associated with ransomware behavior? And if so, let's mark it as such and then make decisions on what to do with that data. Do we take the drive offline? Do we disconnect the host? How do we start looking at pool-level relationships? These 5 drives that are signaling behavioral issues that could be malicious are associated to hosts that belong into these pools. So should we take them offline to prevent the malware from getting to the host ahead of time? That's something that I find really exciting. Those are the services that I would call out here, is how do we start doing things in an autonomous fashion? So we know what the warning signs are from a cyber attack perspective. Typically the out of space, your box is getting bricked because all of that unencrypted data is being ripped off and replaced with encrypted data. We know that some of the malware that's out there will actually not only do a data encryption, but they'll actually delete the host files themselves. We also know that we can actually look at data encryption patterns as we think about the host that we're working with and how they're working with the data that we're storing on disk, whether it's unencrypted or encrypted, naturally or normally, I should say. And then last but not least, are we seeing a lot of heavy reads in times from hosts that normally aren't operating? And those heavy reads are then replaced with deletes, which could be a data exfiltration problem. What I'm sharing with you here, the important thing is this is no different than your everyday car alarm. How many of you have been in the parking lot of a major store or mall, and a car alarm went off, and you're like, hey, there's a problem over there? No, what we do is you're like, man, they need to deal with that alarm. That thing is loud and obnoxious, and we walk right past it. All of the things that I've shared with you today are key components of false positives. And so we have to be very diligent about how we use correlation as a means to drive to a more permanent positive from my perspective. Otherwise, we're going to constantly be throwing up red flags. Because the drive itself, the storage controller even, has no idea that the host may have just said, hey, we've got a new security policy, we've got to turn on encryption on the host. And then all of a sudden, all the writes coming to the controller are going to be encrypted, and we won't know that that's any different from a ransomware attack. What we could do, though, is we could use that inferencing engine at the storage array level to start doing correlation. So what you're looking at here is as we think about I/O patterns that indicate an attack, an encrypted attack that drives to out of space on the drive, what you're looking at here is the ability for us to look at the network traffic and host level activity. And what we're looking for is we're looking at this out of normal experience where random reads and writes, as we would expect, coming through, and then all of a sudden a massive amount of write operations are coming through, and then at the drive level we begin to see something very similar. High reads, high reads, high reads, all of a sudden massive amounts of write operations. So these two correlating pieces of information would be a stronger indicator that there's a ransomware attack underway than simply us saying all of a sudden we saw a bunch of encrypted I/O happening on the drive itself. The other thing that we look at too is when we talk about the attacks from the perspective of what's happening on the network and how the malware is propagating through, is how do you now use that, that information or Shannon-based entropy associated with goodness of fit from maybe a chi-squared kind of a test to compare that to what's going on from the network traffic itself. So the network is reporting that they are seeing malicious code or at least signatures through the network traffic that are malicious in nature. The moment that we see that occurring, then the inferencing engine within the Spectrum Virtualized can take over and begin to watch and monitor that drive, looking for the encrypted I/O entropy window or the compressed I/O entropy window to climb or spike, which would be indicative, again, of an attack, and we can certainly take action on that to prevent the drive from being consumed. Connecting that back to the ransomware recovery operation that I had mentioned previously. And then when we think about the way that ransomware tends to behave, the one thing that I would share with you here is that the common culprit in all of these sort of I/O sequences is the write operation. Right? The write operation is the key indicator for us when we can correlate that there may or may not be a ransomware attack. And so from the perspective of building and developing these drives, the ability for us to ask these questions of the individual components, the ability for the individual components to report back up when it sees things that are anomalous in nature, that's one step closer to helping the vendors that you support start to think about ransomware and detection, prevention, as well as data safeguarding from the drive levels perspective. The last one that I would share with you that we're looking at is how do we start looking at trending based on average usage and what we see as normal behavior of the host that we're connected to from a drive pool perspective. If they have normal reads and write traffic, and then all of a sudden the business day shuts down at 5 p.m., 6 p.m., and then we begin to see an enormous number of read and delete operations that are occurring, that's a good indication of a data exfiltration activity, especially when we're comparing that host-based traffic activity to what we see happening on the drive. Now, I've shared sort of some insights with you about where our heads are at, where we see the next generation of our FlashCore modules going. The ability for us to take ransomware detection down to the drive level is a key capability for us to continue to eliminate the amount of processing responsibility that we put on the controllers in our arrays to do this work for them, or the necessity for organizations to deploy more and more infrastructure to run these kinds of services. And that's something that I'm really excited about. I mean, our goal is to create a foundation for organizations that are based on consistency, where you've got the most secure and consistent data foundation to store the data on, whether that's scale up in block, scale out in file, some unified thing in the middle, something ready for containers, ready for the cloud, you name it. All of that delivering a consistent set of data services to help organizations store and safeguard their data, manage and govern it, certainly extend it to other parts of the business and mobilize it as they see fit. And then certainly a set number of operational capabilities that connect these security measures together. So I appreciate you giving me a moment to share where our vision is at and where we want to go. I'd love to explore this with you as well. You could call us crazy, but I just think it was great for us to be able to get together with you and say, this is what we're thinking. And until someone tells us we're wrong, we're going to keep going this way because it's the right thing to do for our customers. And then last but not least, because you sat here, we've recorded everything about you. No, I just want to make sure that you are aware that these slides will be made available to you for download. I'm certainly available to talk to you more about it, but this is the obligatory policy that I'm asked to put up before I give you this final screen. So with that, thank you very much. I appreciate it. Thanks, Jay.